Today, we are speaking with Luís Cruz, co-founder of GreenSeal.dev and assistant professor at Delft University. Luís works at the intersection of sustainable software engineering and what many now call green AI, an area that is becoming increasingly relevant as digital infrastructure and AI systems consume more energy globally. At Net Zero Compare, we focus on practical implementation, measurable impact, and compliance realities. Software is often overlooked in sustainability discussions, yet it underpins nearly every sector, from finance and manufacturing to logistics and energy systems. So today, we'll explore two sides of Lewis's work: his academic research at Delft University and how that research translates into a real-world product at GreenSeal.dev. Let's begin. Luís, thank you for joining me today.
Well, the pleasure is all mine. Thank you so much, Carol, for the invitation. And it's always a pleasure to talk about these topics and discuss some interesting stuff that can be relevant for other people as well. So I'm excited to be here and having a chat with you.
I'm excited about the conversation as well. So, as I said, let's start with academic work at Delft University. So, if you could tell us, because software rarely appears in carbon reporting, why has sustainability in software engineering been historically overlooked in your view? Because we talk a lot about scope 1, 2, and 3 emissions on this platform, yet software often hides inside scope 2 and 3. It would be really helpful to understand how this blind spot emerged.
Yeah, I think there are many reasons, and it's never a single reason to explain the situation and the context where we are at the moment. But I think that it's mostly because it is a difficult problem, and it is a problem that um, hasn't been solved in other domains. So if you look at sustainability, we have been working on it across all different domains of the human activity, like transportation, um, domestic appliances, food, fashion. And there's a lot of this work in sustainability that easily translates to the IT sector, to the software industry. Um, but when we talk about the software itself, there are some differences that make it difficult to address sustainability at the core of the software. And because of that, we keep discussing sustainability in a higher level concepts, such as whether the IT organization um, produces electricity with renewable energy, or whether they have electric cars and this sort of things that play an important role in carbon emissions, for example. But then it's very easy to forget about the software, which requires a more um, groundbreaking change if you want to make it actually sustainable. So that would be, I think, that the resistance to changes that, I mean, it happens in every sectors, and of course, there's a resistance to change here in terms of sustainability of software, and we still need to do a lot of work to change the behavior of our industry, to change the way that software teams work, to change the way that C-level stakeholders look at the software teams and how they deliver new features. All these things are important, and we're still figuring out how to make sustainability a differentiating factor that actually brings value to all stakeholders in the software industry. Yeah, so I would say that that's probably the most important factor, the fact that this is very new for everyone. We're still figuring out a lot of things. We've done quite some progress in the past 4 or 5 years, but there's a lot more to do.
Yeah, there's way more to do. I totally agree. And thank you very much for that clarification. If you could tell us, when we say sustainable software, what does technically mean? Are we talking about cleaner code, efficient algorithms, hardware optimization, or something broader?
I think it's all of these things. As you know, sustainability is a broad term. So sustainable software, it's also a broad term. But from an engineering standpoint, and by the way, I usually, when I address sustainability, I talk about environmental sustainability. So I'm not uh, discussing economical sustainability or technical sustainability, social sustainability, which is also super important. But I'm focusing on environmental sustainability, which is also one very important dimension of sustainability. And uh, technically speaking, there are many layers. I mostly think about three layers, or three overarching layers. Code level efficiency, so the actual code that is being created, algorithms, data structures, the language choices, yeah, these small decisions that appear in the code when you're creating it. Then we can also talk about architecture and infrastructure, how you design the system, how the different components of the software interact with each other. Uh, are you uh, are you taking down cloud instances when you don't need them? Are you transferring data across contents for no reason, for example? Are you running batches when the grid is with a high carbon intensity? So when are you considering all these choices and trade-offs when you're running your software? And then you also have the product decisions. The way that the product is presented to the users, and this could be the user experience. For example, are you doing infinite scrolling? Are you um, um, do you have autoplay in your videos? Is it really necessary that your videos in the software start playing immediately? Maybe not. So all these small things, are you also considering sustainability there? So I think about these three levels. Speaking of the software, so I'm not speaking of the organization that builds software, but the software itself, the software product. And I like to compare this to buildings, for example. So you don't question that when you're designing or building um, a new building. You don't question that you want to meet energy efficiency standards, right? And I think that the software should be going in the same direction, but we're just in a earlier journey, of course.
And there's often confusion between energy efficient hardware and efficient software. It would be useful to clarify where software design really makes a measurable difference. Do you know, and could you share with us any real cases?
Yeah, so when you talk about energy efficiency, it's very difficult to separate hardware from software because obviously a piece of software that is super efficient in a particular hardware architecture might be not efficient at all in a different type of hardware. So we always need to consider these two things at the same time. So the software you build needs hardware and you need to take into account. And that's also why it makes it so complicated to uh, prove and certify energy efficiency. This is actually a mistake that our industry has been doing in the past. The fact that we think that we can just give a stamp on energy efficiency when there are so many other factors. But um, when you're building um, this software, there's also the question of uh, this is going to run in the most energy efficient hardware. but is it also compatible with a slightly less energy efficient hardware that while running this software is not so efficient? But I don't need to ask my customers and users to buy a new hardware. They can use the old hardware, and because of that, they will have less carbon emissions from producing that said hardware. So this is kind of such a big system with so many factors. But when we talk about energy efficiency, we also need to consider these other aspects. Um, and this is what we have been seeing in AI, for example, that everyone is running to and racing to buy new GPUs, while 2-year-old GPUs are completely obsolete. And they want the most energy efficient GPUs because electricity is a scarce resource for the AI industry. Um, and we might think, oh, it's going to be energy efficient, so we're going to be more sustainable. But it's actually the other way around because we're just disposing completely recent GPUs that could do a great job. So yes, that's why I'm a bit careful when I uh, try to optimize only for one single metric, only for energy consumption. There are a lot of factors that need to be considered. And uh, I believe that we can talk about very specific cases where software, for example, when we're training a model, do you actually need to train or can you just fine tune it and then spend less energy? Do you actually need this super complex model to solve that task? Can you also use a smaller model and save a lot of energy? All these trade-off questions that you need to use. That's where I think the difference in terms of software products will start arising when we are able to analyze trade-offs between value to the user and the actual energy consumption.
So, as always in such cases, the key to the success is finding a happy medium, a balance between all those different factors that you've just described.
Exactly, yeah. So I think that's the main takeaway of everyone that is studying or that is working in this space. You can never really optimize for only energy efficiency because you might just go out of business while trying to do it. You also need to consider value to the users. You also need to consider performance. You need to consider a lot of things, but you should also consider environmental sustainability, which correlates a lot with energy efficiency in some cases.
And in your research, where do you see the biggest energy inefficiencies in modern software systems?
Yeah, that's a good question. So of course we all talk about AI, but I think we can look at the past. We should look into history, um, because of course we're now witnessing a breakthrough, a big change in the software industry with AI code assistants and coding agents, and of course this is shown as a major improvement in productivity and these sort of things. So I'd like to look back a bit and go to a few centuries ago when we were in the Industrial Revolution and we were witnessing counterintuitive pattern. So steam machines, the steam engines, they were becoming more and more efficient. And with this efficiency, this that would mean that we would spend less coal. We would need less coal to run our businesses and our industries. But we are actually increasing the amount of coal needed in the whole industries around these different countries. So this is kind of a paradox, and it's often called the Jevons paradox because it happens in every single sector. So as soon as you increase productivity or efficiency, you don't reduce the consumption of that resource. You actually increase the consumption of that resource. So it doesn't mean that it happens all the time, but it happens a lot of times. And we also call this the rebound effect. So we make the software super efficient. We have a programming language that will make things super efficient, but we're gonna use more of that energy. We're gonna use more of that resource. So how does it apply in the next few months, years of this AI breakthrough? So I think there will be an explosion of software being developed. Software will become even more disposable and will be generated just in time to meet the requirements and needs of users on the fly, because it's super efficient to generate new code, to generate new apps. You don't need a super team of developers. You just need a few agents that will generate the code for you. So you don't need to, you can just generate things on the fly. So in the end, we're going to be generating a lot more software, and it's already happening. And generating this software, it will be as expensive as the energy that it spends. So it's going to be about electricity and CPUs. So I'm a bit concerned that instead of, and while we're making these AI technologies more efficient, with new GPUs and with new models, new techniques, um, this will actually increase the energy consumption of the AI industry and the software industry. So it will make developers more productive, but without guardrails, it will actually multiply the environmental footprint of software by manifold.
Got it. You just mentioned that AI models are growing in size and complexity. So, from an academic standpoint, how significant is the environmental footprint of large AI systems in your view?
Yeah, that's a good question. I think we've all been discussing this in the past years. I think in terms of awareness, I think everyone understands that these AI models are power hungry, that they are not just a small lightweight thing running in our devices. It's running in big data centers. And of course, the models, we can talk about training them and how expensive it is to train a single model. And it is super important, but it's a one-time cost, right? Um, which is a quite expensive one-time cost, but the real concern is in inference, right? The fact that users are querying these models billions of times a day. That's where the energy consumption lives, and it will scale directly with adoption, with the new use cases that we are creating around it. But the footprint goes beyond electricity again, right? So there's a physical supply chain behind every GPU: mining, refining, um, manufacturing, shipping. There are a lot of rare earth minerals, materials like lithium, cobalt. All these materials are required to produce the GPUs, and they have some sort of a life cycle. And this life cycle sometimes is not as long as we would expect. So again, this connects with the Jevons paradox, because even if AI models don't consume energy directly, they will actually require more and more hardware. But again, I don't think the right question is whether we should stop building AI. So I'm not, although I'm saying this, but I'm actually in favor of all the innovations and all the amazing things that we have with AI. But the question should be, are we building AI for the right problems, and are we doing it efficiently? Um, a model that optimizes, for example, a power grid or reduces fuel waste. So this is actually saving more energy than it consumes, right? But the problem is when we deploy massive models for trivial tasks or useless tasks. And we've seen a lot of that, for example, in social media and a lot of other use cases where maybe it's just a waste.
I was also asking because there's a lot of hype and fear around AI's energy consumption. So I think it would be helpful to focus like on actual data and trade-offs. Do you have
Mhm.
any examples?
Yeah, for example, training a model like GPT. Of course, this is we don't have like real numbers. It's mostly estimations. But for example, training ChatGPT um, was known to emit the equivalent to 1,000 cars driving 1,000 kilometers. And this will be just training a single time. So we know that training a model like GPT requires a lot of experimentation, requires a lot of iterations before we boil it down to the version that we have to the public. And of course, now we have not only one version of GPT, we have all these new versions, new fine-tuned versions, and new players coming into the race. So that's one number. But then we expect the inferences to be even more pressing in terms of uh, footprint. Because I don't have the current number because it keeps increasing every day. But 2 years ago, like the ratio between inference and training would be like 1,000. So and I'm pretty sure now it's a lot more.
And it's pretty dynamic, so everything changes every single day.
Yes. It's very difficult to keep up, and the companies are not very transparent about this. So, and this is something that um, uh, many companies that consume these AI services from OpenAI, from Anthropic, from all these big players. So many of the companies that are customers of these services, they ask for a number. They really want to know what is their footprint while doing all of this. But the numbers are so covered because this is also a problem of the way they present to the world, and I don't think they see the value of becoming more transparent about these numbers.
And in your view, are universities adapting fast enough, or are computer science students being trained to consider energy efficiency as a core engineering constraint? I'm asking because if sustainability isn't embedded in engineering education, I think it becomes much harder to fix later at scale.
Yes, that's a very good one. So a lot of universities care a lot about this. I'm quite impressed with the a number of universities that now have uh, um, green software concepts embedded in their curriculum. Um, and I receive a lot of contacts from professors that want to create these kind of courses within the computer science and AI curriculum. So that I think that is changing, and we see a lot of progress. A few years ago, there were no materials about this topic, so it was very difficult to get it started. So I'm actually super proud of having started this course on sustainable software engineering, where a lot of materials were created from scratch. Nowadays, we see a lot of content out there, so it is changing. And uh, I am with you on this one. So if the new generation of software engineers and AI engineers, if they have a bit of literacy, or if they were exposed to these topics, they will be able to make better decisions that sometimes don't have a big overhead because they are also considering sustainability. Sometimes the big bottleneck is just having the mindset to consider it. So I'm quite happy that now we see um, in Delft, Amsterdam, also a lot of universities in France, in Portugal, they have this content. Sometimes they don't have a specific course to talk about this content, but they have like 2, 3 lectures, which is not a lot, but it's something. 2, 3 lectures in the software engineering course, or the programming language course, or the AI at scale course. So they they talk about broader problems, but then they can also have 2, 3 lectures about this, and it's super easy because there's content out there. So I've been witnessing a change there, a progress there, which is great. What I've also been witnessing is that at the industry, we're now reaching a plateau, while the universities and the academic curriculum are developing and making progress. At the industry level, somehow we're reaching a plateau. That's the feeling I have. So, and I believe this is also related to the fact that we now have very mature GHG reporting frameworks that allow software companies to report carbon emissions, that somehow they forget to go back to the basics and to go a bit lower at the low level, at the core level of the software teams, and enable them, encourage them to actually become more energy efficiency aware. Um, So yeah, I think at the university level, we're not there yet, but we're making a lot of progress. And I challenge any educator out there to look through these contents and to check out if there's anything that would fit their courses and what they teach to their students, because I'm pretty sure they will be um, quite excited, as I am, to share this with their students.
If I understand correctly, you can already observe a change, positive change, but of course, still universities could adopt it at a faster pace.
Yeah, not only adopting it, but at the past, if someone would bring this up in a job interview, or if we would approach software teams and say, "Hey, I'm developing this tool, or I actually care about doing this training on green software," they would immediately absorb it. They would immediately say, "Hey, this is actually something that we are looking for, that we really want to adopt." And nowadays, it's more like, hey, we're already doing carbon reporting. We're already doing FinOps. So it's like we already have a team working on that. We don't need to worry about this topic anymore. I'm not saying this is happening everywhere all the time, but this is something that I've been exposed to that used to be received with a lot more enthusiasm than I see now.
And from a research perspective, what are the most promising technical approaches to reducing software related emissions over, let's say, the next 5 years? Are we looking at better measurement tools, new programming paradigms, green and AI, or maybe model design, or even improved cloud orchestration?
I think uh, I think all those are super important, but I would say that they will rise as a consequence of something else, which is um, something that I was just talking about, which is the encouragement of software developers to actually build green products. And for that encouragement, one important thing that is missing is monitoring, um, monitoring metrics that resonate with the energy efficiency of the product. At the moment, we have two main lines of thought. One is that we need to have very precise metrics and methods to report the energy consumption of software. And there's another line of thought that I prefer, which is we don't need super precise metrics. We don't even need to talk about the energy consumption as long as we have metrics that are much simpler to collect, that developers can easily understand and take action, and somehow um, correlate with energy consumption most of the time. So we accept that there will be an error, that some cases we won't be actually minimizing energy consumption, but at least we have an idea. And this kind of unreliable metric is more likely to be adopted by software teams because it has low cost. It has everyone can easily install the tool or interpret the monitoring tool and take action. And if we spend too much time measuring, then we're already uh, asking developers and companies to spend a lot of money just measuring, and then we won't have enough money or budget to actually take action. So so we're um, what I see that in the next 3-5 years things will develop and we'll actually be able to make a change is in um, empowering software developers and AI developers to actually build energy efficient stuff. So we start by measuring, and then we start by recognizing improvements. So measuring, I'm on the team that we accept errors, unreliable metrics, but that allow us to have a direction and to take action without doing these and the other rules.
Learn from mistakes.
Exactly. And then uh, learn from mistakes. So and then we improve it, and then we take action. And this action needs to be recognized within companies. Um, so they need to see the value of having a team that says, "Hey, we already have these features implemented. They are in production and they're working, but they are not energy efficient. Can we spend a couple days testing out a different way of doing this that would be more energy efficient?" And then the company should have enough incentives to say, yes, we can actually spend time and money on it because our customers, or the context where we are, will actually be able to perceive this value. And this kind of system is still not there. And this is where I'm expecting, and where I think that the next 3-5 years will actually develop a lot. It's in this system. Um, I don't have a solution, a clear solution, because we first need to do our homework, measuring, and then empowering teams. But I believe that maybe with um, certification, with transparency, this will become naturally um, some forces that will um, promote the creation of green products.
And now I would like to talk to you about your work at the GreenSeal.dev. If you could tell us what led you to co-found GreenSeal.dev, what gap did you see between academic research and what companies were actually doing?
Yeah, that's a perfect timing for this question because, as I was just saying, we have the problem of measuring, okay? And then if you know how to measure, if you can measure and monitor, you have the problem of empowering teams to do so, to take action on it. So I'm trying to empower software teams to actually improve the energy efficiency of the software. I'm also trying to recognize the teams that are already doing it because they care, because they are into it, and I want them to be recognized and to be able to add value to their businesses by doing that. So this was the gap that I wanted to uh, to solve in the software industry. This is the change that I want to see in the software industry. I want to make software and AI industry green by default. So it shouldn't be super expensive to be green. It shouldn't be something um, that makes you question your budget and your finances. It should be something that you do it because you know it's worth it. Um, so the approach for that gap, or one of the approaches that I'm trying to propose to solve that gap, is certification. Um, and there again, I looked at the existing certification for sustainability and for energy efficiency, and I saw two major groups of certification. On one side, the certification that focus on something that we already discussed today, which is um, sustainability at the broader scope. Like if you're um, if you're using renewable energy, like today operations that apply not only to software but apply to many different sectors. And we have many interesting standards and certification around this, like the B Corp, the ISO 14001, and a lot of other great initiatives. They miss the software product. And then I also saw another group of certifications that actually target the software product, but I wasn't happy with them. I wasn't happy with them because I wasn't seeing how it would actually reflect a team that is genuinely creating a green software product. And I'm going to explain why. So we have uh, two big certification. One is the Blue Angel in Germany. And basically, they do a few checks and they require you to measure the total energy consumption of a use case of your software, and then you report it, which is great. And then they also ask you to report whether your software can run in devices that are up to 7 years old, which is also a great thing. And a few other checks like this, which I like a lot. But then my problem with that is, um, first, if you only report energy consumption, it says very little about the energy efficiency of the product. If you're talking about home appliances like a washing machine, it's easy to differentiate and compare between different products because they do very concrete and similar functions. When you're talking about software, they are all doing different things. Maybe some of them have similar use cases, but they are not doing the exact same thing. They usually innovate with some new stuff, some other things. So if you use the energy consumption to compare, you're forgetting the context. You're forgetting a lot of other variables that are important and that might bring user value. So you cannot just use energy consumption in an isolated way. And the other thing is you might have measured it in a particular hardware, and then you have this number of joules. But if you change the hardware, then you have a different number. So how do you actually take action as a consumer um, to decide whether you go to one or the other product? And there's very little to do that. And I could go on and on with examples related to this, but I proposed a different approach. I propose that, again, we empower the developers to make sustainable decisions about their software. So I'm not checking the product itself. I'm not checking the organization carbon footprint. I'm checking whether the process to develop the product enables the people involved, the developers, the designers, the product owners, to actually build energy efficient and carbon efficient and environmentally friendly products. And I'm going to give you a few examples. Um, if if you have a dashboard that will continuously say how much energy was consumed um, um, throughout the whole life cycle of your software application. So version A, version B, version C. So you know how much energy was being consumed. If you have a dashboard that you can see as a developer, you know that the latest code change that you've made increased the software consumption, software energy consumption by 5%, by 2%, 10%. If you know this, while you're creating the product, you can take action. You can say, hey, wait, my previous code change was doing something that I wasn't expecting, and maybe it's not worth it. Or maybe there's a different way. Let me try it out. So, so by doing this, by creating awareness in the software development lifecycle, you can actually build green products. And at the moment, what we have is a big um, chunk of the software lifecycle that we never talk about energy, never discuss energy. We don't care about it. And then we go to the end of the moment where we have the product deployed, being used. And then we have one moment where we certify the product, which is what the existing certifications are doing. We have that moment, and then that's it. So that's not what we want. What we want is something continuous, something empowering, and something that will recognize the effort of these developers. So then we actually have lightweight things that some companies are already doing. For example, um, one thing that we require in this certification, this Green Software Practices certification, is do you share your experiences optimizing energy consumption with the community? Do you share it? Do you share it internally in your company? So that you're actually telling the rest of the world how to be energy efficient in your concrete context, because no energy efficiency optimization is the same, so they all depend on context. So if you do so, if you share this knowledge, we can go way beyond the existing energy patterns that we have out there. We as a community will learn a lot more on how to build energy efficient because we are collectively working on it. So this is what we're trying to do at GreenSeal.dev. We're trying to change the software industry. We're not just trying to talk about sustainability and bring it to the conversation. We're actually trying to change the way we design sustainable software.
And many academic insights never reach the market. So it's very impressive to see cases like yours, where you managed to move from research into product development.
Yes, yes, I'm quite happy about that. Let's see how far it goes because it's always a big challenge to bridge these two different big worlds.
Oh, yeah.
But it's how research should be done, right? So there should always be a bridge and a two-way communication and interaction. Of course, it's a difficult problem,
Exactly. There is a factor of luck, as we know it also.
for sure.
And if you could tell us what exactly does GreenSeal.dev measure and how does it integrate into a company's development workflow?
Yeah, so of course at GreenSeal.dev we have the certification, which is our core proposal to the software organizations. We also provide training and we also provide roadmaps for companies that want to step up their sustainability game, of course. But what we mostly measure, and by measuring, I don't mean as a way of scoring companies, but more as a way of giving them a roadmap and giving them um, um, a vision that they can use develop and to be more sustainable. So what we give is some sort of we measure the maturity of their processes. We measure um, um, how their processes are actually enabling these energy efficiency values. So in a way, this is what we measure per se, what we offer. But of course, internally, this means that we also bring a lot of energy consumption tools, a lot of uh, tools to improve the productivity of developing teams, tools to improve the way they test their software. So we believe that it's not only about energy, so you also need to improve the quality and maintainability of your product and review the dependencies. So we bring a lot of tools that not only measure or give a metric, but also allow developers to have the right information to make the right decisions.
And how would you describe your tool? Is it more like a developer tool, a reporting tool, or both?
Um, I would say it's both. Um, so at the higher level with this certification, it's more of a reporting. But then while reporting, we actually, some of the requirements we have require uh, the use of certain tools that will allow them to build energy efficient code. So we operate at these two levels, the level of reporting, to show that the lower level, the level of tools, the level of implementing this in the day-to-day practice, actually has visibility to the higher up stakeholders.
It. And how does sustainable software connect to regulatory frameworks like CSRD, which is Corporate Sustainability Reporting Directive, or broader ESG disclosures?
Yes, so that's a good one, and that's where um, I usually try to make sure it's clear because, as I was saying, the existing certifications don't really focus on the same gap that we're working. So it's very important that we create a map of all the existing regulatory frameworks and certification processes and standards. So, for example, ESG reporting, um, they rely a lot on the GHG protocol, where you report the scope 3, scope 2, scope 1 carbon emissions. And this works quite well at the C-level stakeholders, like CEOs, DOs, because they feel the pressure to report these numbers and their customers and their providers. There's a system that really consumes this data, and that's where the existing regulatory frameworks operate. And that's why I also think that they are uh, insufficient, and that we need more, because under all these reporting, under all these regulatory requirements, a lot of uh, questions and issues around the actual software product that is being created is overlooked. There are a lot of blind spots there. And that's where the GreenSeal.dev certification works better. So that's if I could create some sort of map output existing regulatory frameworks on sustainability up here, like sea level, communication inter-organizations, and then I would put the GreenSeal.dev certification under that at the core, at the software processes, at development processes, the products that are actually built. One could say that, oh, we need higher level discussions because this is how the world is able to visualize and operate. But I could also say that's super superficial. So we need actually to go to the core of the software industry, to the actual software that is produced. That's how we actually change and we avoid things like greenwashing and that we're witnessing currently, where having an image of sustainability is more important than building sustainable products. Something is wrong with that. Someone needs to fix this problem, and eventually, I think everyone will realize this. Maybe in the future these frameworks are developing and they will be able to scope the whole the layers of the software industry, but at the moment we're far from that.
I was asking because for many companies, as we know, sustainability efforts accelerate once reporting becomes mandatory. So it was good to see where does software measurement fit to your software fit to in compliance. That's great. And in practical terms, where do companies see the strongest business case for greener software? Is it cost savings, cloud optimization, reputational risk, or procurement requirements? These are like top three that come into my mind.
Mm-hmm. So, and then those are some of the biggest reasons. I'd say that regulatory reasons are the most pressing at the moment because a lot of things are coming out, and especially with the AI Act, we already see that the European Union is asking to measure and report energy consumption of AI models um, when they are critical. So we already see this, and the companies are trying to stay ahead of the curve and prepare for that. And the other is procurement. So we see that a lot of other companies want to be recognized and to be perceived as sustainability players in the industry. This is a way of differentiating against some well-established players that usually don't care about this, and then we see good examples. So, for example, we have a Green PT, which is basically trying to compete with ChatGPT, providing similar services, but mm, providing it in a way that is sustainable, GDPR compliant, using renewable energies. So, so this is a differentiating factor, and I think it's something to be recognized. So to me, if I would have to come up with the top two, these would be the main ones: compliance and procurement. Yeah.
That's great. At Net Zero Compare, we are always interested in where sustainability aligns with financial logic rather than just purely ethical motivation. So that's great to hear your insights. And now, my final question: is there anything we didn't touch on today during the conversation, either from your academic work or GreenSeal.dev, that you believe decision makers should better understand?
Well, maybe 2 points that I'd like to share. One is I see a lot of um, companies that are like, oh, we don't want to do this because it will be uh, uh, a major effort in terms of our budgets. But sometimes they're already doing a lot internally, and they have a lot of developers that already care about this. And it's not like they would have to do a major effort to actually become sustainable. That's one thing that sometimes I have to discuss with some of the companies we talk to. Sometimes they think that it's about 80% of the effort to improve 20%. So they have this kind of feeling that it's not worth it, that it will be a lot of work, and then just to have a minimal benefit, which is not the case most of the times. Most of the times, it's just about avoiding overlooked terrible decisions. It's that the engineering teams already know about them, but they're like, it's working. Let's not change anything. But it's actually something that will make everyone happier within the organization. That's one thing I would like to share. Um, the other thing that I like to share is um, sometimes we see we make the mistake of blaming existing players in the software industry, existing corporations, and I don't think that's the best strategy. I think the main message that we want to give to every professional, to every organization, is that everyone has a role to play, and everyone is figuring it out. It's okay to make mistakes. Uh, it's because, for example, sometimes companies are too afraid of reporting energy data because they don't know the consequences in terms of image with their customers, or how people will criticize it. So they prefer not to disclose anything. And I think this is a mistake that we as a community, especially in the sustainability community, sometimes we are too quick to judge. And I think we need to change. We need to be more inclusive. We need to bring everyone to discussion, to make everyone feel part of the solution, and don't give a label to organizations and say, oh, these are the problem. They can also be the solution. It's easier if they are the solution.
I totally agree. And going back to your first point, I think when the process is managed properly, the example you gave that companies think that 80% of effort will translate into 20% of improvement. I think when it's managed properly and well, then 20% of effort can translate into 80% of improvement, right?
I am with you 100%. Yes.
Luis, thank you for sharing your insights. This conversation highlights something critical. Sustainability is no longer just about factories, transport, or energy systems. Software is infrastructure. AI is infrastructure, and the decisions developers make every day have measurable environmental consequences. So, thank you very much once again for joining me today.
Thank you. And thanks again for the invitation. And it was super wonderful to have this conversation with you. So thank you so much.
My pleasure. And we'll publish the full article and insights at netzerocompare.com. And for those listening, make sure to follow, subscribe, and share this episode. Thank you so much.
Cheers.